Good afternoon. My name is John Matthew Rohasil, and today I'll be presenting my extra credit work, The Laws of Thermodynamics. I'm from the group 10-3, and this is for ESL class. I hope you guys enjoy. The laws of thermodynamics. The laws of thermodynamics are three concepts that helps us learn how energy flows in certain directions and in certain ways. The three laws can be explained in simple ways, but the math that's behind it all makes it almost impossible for me to understand it. So I'll be explaining it as much as I can. The first law of thermodynamics. One can call it the first law, but it's also known as the law of conservation of energy that simply states that energy cannot be created or destroyed. Simply, it takes a form that can be transferred to one another. For example, turning on a light will seem to produce energy. However, it is electrical energy that is converted. And we can see the letter A, we can see an example that shows us how it works. Here you have a cubes and una balanza. There you can see the energy before and then the energy after. It didn't change it doesn't change the cubes. It hasn't changed the cubes. It just it just passed the energy, and we can see that it didn't change anything at all. It just changed the appearance. The formula. The change in internal energy of a system is equal to the heat added to the system minus the work done by the system. Triangle U it states that change in internal energy equal Q, the heat added to the system minus W, work done by the system. The second law of thermodynamics. The second law of thermodynamics states that the entropy of any isolated system always increases. If you wonder what entropy is the measure of a system's thermal energy per unit temperature that is unavailable for doing useful work, because work is obtained from order molecular motion. The amount of entropy is also a measure of the molecular disorder or randomness of a system. For example, the melting ice caps. Here we have an example of how the second law of thermodynamics. The third law of thermodynamics. The third law of thermodynamics states that the entropy of any system approaches a constant value as the temperature approaches absolute zero. For example, steam is the gaseous form of water at high temperature. The molecules within it move freely, and hence it has high entropy. Excuse me. If you cool this steam to below 100 degrees Celsius, it will get converted into water, where the movement of the molecules will be restricted, resulting in decrease in entropy of water. Here we have an explanation of how it works. In the first little jar, we see the decrease in temperature. You see there the balls are literally separated and it's decreasing in kinetic energy. If you wonder what kinetic energy is, kinetic energy is a form of energy that an object or a particle has by reason of its motion. Kinetic energy is a property of a moving object or particle and depends not only on its motion but also on its mass. In the second jar, we see more decrease in temperature and more decrease in kinetic energy. In the last jar, we see zero kinetic energy. As we stated, if the temperature approaches absolute zero, it will be cold. It'll all be super sticky. They'll all be formed together. The formula. The entropy of a pure crystalline substance at absolute zero is zero. Let me explain this right now. S is entropy equals to K ln ln which W is the number of microstates, equals to K I n 1 equals zero. That's the explanation. Now, Thank you for listening. I hope you all understand the way I said it to you guys. Like I said, I did my best. I'm not a mastermind of explaining this, and I just hope you guys like it and have a excellent have an excellent afternoon.